My dear student, how are you? I think all of you are well. Today I am going to conduct another class. So welcome to Amader Pathshala, presented by Manipur Uccho Vidyalaya and College. Before going to our main discussion, I would like to draw your kind attention to my previous class. That is, what was my previous class? That is the review of the previous lecture. My dear student, in my previous class, I discussed about something which is related to this figure. Can you remember what we have learned? Yes, of course. We have learned in our previous class photoelectric effect. And then, what is meant by threshold frequency and or function of a metal 2.1 electron volt, what does it mean? And some other mathematical problems related to this. So basically, in our previous class, just we have learned about photoelectric effect and its defect and its different terms, and finally solve mathematical problems. Now I am going to take another class on this chapter, but just before this, just see in my slide. Do you know the person who is available in my slide? Yes, all of you know this person is very familiar and prominent scientist, and his name is Einstein, that is Albert Einstein. So can you guess what we are going to learn today? Yes, we are going to learn today about relativity. So our today's topics: Relativity, Chapter 8, Introduction to Modern Physics, Lecture 2, Physics second paper for class 11 and 12. So what we learned at the end of my lecture, my dear student, that is learning outcomes. At the end of the lecture, student will be able to know what is relativity, what is transformation, is there any difference between Galilean Transformation and Lorenz Transformation, and know about inverse transformation. So this is our today's learning outcomes. So from this learning outcome, you know that first of all, you know relativity. So what is relativity? According to classical physics or classical mechanics, length, mass and times are considered as absolute, but according to Einstein, these are not absolute, rather relative. This theory of Einstein is called theory of relativity. From the ancient time, my dear student, we think that mass, time and length are absolute, that is, they are not changeable. But at the age of modern science, that means after 18th century, the invention of relativity by scientist Einstein, this conception has break down. Now we know that time, mass and length are also changeable. That means they vary with their velocities. So is there any types of relativity? Of course. There are two types of relativity. Number one, general theory of relativity, and number two, special theory of relativity. Now, first, general theory of relativity. General theory of relativity, that is the branch of relativity that deals with the object of the system which are in high or low motion with respect to one another. It's called general theory of relativity. That means if two or more systems or objects are in motion and if they have acceleration, that means their change of velocity, that is high velocity or low velocity, in this case the relativity described, basically this is known as general theory of relativity. So what is another one? That is, what is special theory of relativity? The branch of relativity that deals with the object of the system which are in uniform motion with respect to one another, is called special theory of relativity. So my dear student, what is the difference between special theory of relativity and general theory of relativity? A question is for you. But for your convenience, I am going to tell 1 or 2 points on this base. Number 1, general theory describes the system where there is a relative motion, not only relative motion, they have high or low velocities. That means their velocity in variation. And on the other hand, a special theory of relativity, when both systems or mediums or the frames are in uniform velocity. That means their velocity always remain constant. Now, how this theory comes to us? You know that any theory established or comes to us depending on their postulates. Do you know what is postulates? Yes, it's a special theory that comes from the general statement and based on this statement. That means any theory, any scientific theory comes from the general statement and forms the base of this statement is known as postulates. That means before going to theory, just you have to know about postulates. Is there any postulates? Anything more about postulates you know? Of course. Postulate basically gives the mathematical relation between different variables or quantities or physical quantities. So, output of this postulates, the mathematical explanation. So, in this case, a special theory of relativity basically depends on some fundamental postulates. And you know those how many postulates are there in special theory of relativity? Of course, there are 2 postulates related to this. Number 1, first postulates, the laws of physics are expressed in same form in all inertial frame of reference. That means all laws are in same form in all reference frames. And second one, in free space, the speed of light is same for all frame of reference. That means speed of light remain constant in all frame of reference. So my dear student, here you know something known, that is frame of reference. Do you know what is frame of reference? Yes, of course. You have learned coordinate system, where you know that to locate the exact position of a body, you need to learn about coordinate system. So reference frame is nothing but a coordinate system where I have 2 or 3 axes and also have a origin. Now I am going to tell about the definition of reference frame. What is frame of reference? My dear students, just see in my slide. A specific coordinate system in 3-dimensional space with respect to which the motion of a body can be described is called frame of reference. That means a coordinate system in 3-dimensional space basically describes the position or the motion of a body is called frame of reference. But in this case, I am going to tell about some special types of frame of reference, that is inertial frame of reference. Inertial frame of reference is a special type of frame of reference where Newton's law of motion or law of inertia can be valid, can be applicable. So definition comes in this form: the frame of reference in which the law of inertia and Newton's first law of motion is applicable is called inertia. It's called inertial frame of reference. So this is a special type of reference frame where Newton's law can be proved. Now I am going in details of this. This is a frame, you know this is a coordinate system having 3 axes, x, y and z, and this frame is known as S frame. Another frame where the coordinates are x prime, y prime and z prime, and this frame is denoted by S prime. So S and S prime are 2 reference frames where the frame S prime moves with the velocity v only along x-axis. For our convenient, we just consider the frame S prime is moving only x-axis with the uniform velocity v. So, what are the difference or what is inertial frame of reference? Yeah, these two frames are inertial frame of reference is a question for you. If any frame moves with the equal speed of earth, then this frame is considered as inertial frame of reference. But if any frame moves in a rotational way or any body moves in a rotational way, then this body or the frame cannot be considered as inertial frame of reference, because if any body or any reference frames moves in a rotational motion, then it has acceleration or deceleration. So there is a change of velocity. This rotational frame cannot be moved in uniform velocity. That's why this frame does not consider as inertial frame of reference. Now I am going to tell about these are the two frames. What happens? The equation of the coordinates between these two frames for a simple events. Suppose in this frame moves with the velocity v, then acceleration, you know that if any body or anything moves uniform velocity, then there is no acceleration. So in this frame acceleration a equals to d square r by dt square. In this case r basically represent the position vectors or the position, and these can be written as there is no applied force, so F will 0, that means d square r by dt square will be 0. That means you can write this d square x by dt square is ax is also 0. Similarly, ay is also 0 and az is also 0. That means in this case there is no relative motion, there is no change of velocity, that's why acceleration becomes 0. Now I am going about to tell about non-inertial frame of reference. This is non-inertial frame of reference. What will be the definition? My dear student, in this case the frame of reference in which the laws of inertia and Newton's law of motion is not applicable. That means this frame you cannot derive Newton's law of motion or law of inertia. So this frame is known as non-inertial frame of reference. Just think, you are in a bus, moving bus, and in this case bus is moving with uniform velocity, all the doors and windows are closed. Suppose this is a moving train, let alone the bus. In this case, if train is suddenly brake, what happens? You will see that the ball is rotating, though there is an external force on this ball, but the ball is in acceleration, has an acceleration. This is, though there is no external force. Why happened this? Because we are observing this from a non-inertial frame of reference, that is moving frame. And this is the example. You can make so other example like this. So what will be the equation of this frame? Suppose this is the frame S having coordinates x, y and z. Another frame is S prime, that is the coordinates x prime, y prime and z prime. In this case, the frame S is moving, S prime is moving along x axis with the acceleration a naught. Then any particle in this frame seems to be in motion with minus a naught acceleration. Then a body which is basically in rest in frame S moves in acceleration a, then from S dash frame it will be a minus a naught. That means, my dear student, I repeat this portion again. Suppose a body, suppose this frame S prime is moving along x axis with an acceleration a naught. So a naught is the acceleration of the frame S along x axis. So any particle from this frame S frame seems to be in motion with an acceleration minus a naught. And if you consider another body that is in x frame, which is basically in stationary, if consider this body moves with an acceleration a, then from s prime, its acceleration will be a prime equals to a naught minus a naught. This is the respective discussion. Again I repeat, this is the frame for s prime with respect to s, a naught, and with respect to s prime, this s frame will be in motion minus a naught. And if we consider another body is in stationary at s, seems to be in acceleration a naught, then the particle of the stationary body or the acceleration a in s frame, if we measure from s prime, then the acceleration will be a prime bar equals to a minus a naught. And if the mass of this body is m, let us consider the body is m, mass of the body is m, then its acceleration will be in this frame s prime will be f prime equals to m a prime. Putting the value of a prime, that is a minus a naught, you will get m bracket of a minus a naught, just multiplying in both sides m a minus m a naught. And in this case m a is the applied force, and if you consider this is f, then you can write f bar prime equals to f prime bar equals to f bar minus f naught. If f equals to 0, that is applied force in s frame is 0, applied force in s is 0, that is f equals to 0, then you get f prime bar f vector bar equals to minus f naught. So this is a hypothetical, as there is no force on the particle, but from this s prime you are getting a force. This is basically a hypothetical concept. So this is frame, so this frame is not an inertial frame, this is a non-inertial frame, because in this case law of physics cannot be proved. Now I am going to tell about Galilean transformation, but before this you have to know transformation. But student, you know that if a position of a particle is measured from two different frames, will be difference, can be represented by two sets of coordinates. The relation that basically establishes the relation between these two coordinates is known as reference, is known as transformation. And basis on realistic view, a scientist Galileans make a transformation, made a transformation which is known as Galileo Transformation. So Galileo Transformation is basically establish the relation among two sets of coordinates of two events happen in two reference frames. Now I am going to details in a figure. This is the frame S having origin O, another frame O prime. You know that these two frames are in same position. That means at the time t equals to 0, these two frames coincide with each other. That means having same position. In this case, if you see that the frame x prime is moving along x axis with the speed v, and the event at point P whose coordinates is x, y, z, measuring by the observer in S frame and the observer who is in frame S prime, that is maintaining positioning at O prime, measure the coordinates x prime, y prime and z prime. So these are the coordinates of event P, x, y, z only for the first frame, that is S frame, and x prime, y prime and z prime for the S dash frame. In this case, what is the relation between x and x prime? My dear student, you observe this clearly, then you can see that x frame and x dash frame establish this relation, this x prime is equals to x minus vt. So this is the measuring distance by the same events of the two observer in two frames. Now y prime equals to y and z prime equals to z, as I consider the frame is only moving along x axis. So there is no relative motion along y axis and z axis also. In this case, time t prime is also t, that means measuring time for both this case be same. then the equation that I have got, this is the equation, and this equation is known as Galileo transformation. Now, I am going to tell about this transformation related to the velocity. If you know that if we take the rate of change of displacement, then we get velocity. Now, I am going to tell about what is the condition of velocity in Galilean transformation. Just see the equation. This is the rate of change of displacement, that is dx prime by dt. This can be written by vx prime, then simply d by dt, putting the value of x prime, that is x minus bt, and if you derivative this portion, you will get dx by dt minus b, and dx by dt is also the vx. So, vx prime equals to vx minus b, and vy prime is also vy, and vz also the vz, because in these two axes is considered has no relative motion. Only the relative motion is in this frame, that is x axis. So, this is the formation takes place, transformation takes place along x axis only. So, this transformation is absolutely right or wrong? To know this, you have to know the limitation of Galileo transformation. You know that the first case, the laws of electromagnetic theory be different from in two different frames according to Galilean transformation, but which is make the contradict with the first postulate. Another one, the speed of light is also be different for different frames according to Galileo transformation, which also contradict our second postulate as the result obtained we get from the Michelson and Merlin's experiment. So, this is the equation C prime equals to C minus B. So, that means speed of light changes with the velocity of the body. This is not acceptable also. This is the contradiction of the Galileo transformation. To solve this problem, we just read another theory of transformation, that is Lorenz transformation. That means by Lorenz transformation, this problem can be solved. So, Lorenz basically tries to minimize the limitation that we got from Galileo transformation. So, the transformation laws where the electromagnetic equation remains invariant from one frame of reference to another frame of reference is known as Lorenz transformation. So, this is another transformation where electromagnetic theory or electric theory be invariant. That is not proved by the Galileo transformation, but in this case this law can be proved. In this case, it is considered a frame having x prime, another frame is x, and in this case this x prime is moving along x axis with the velocity x. Now, from Galileo transformation we get x prime equals to x minus bt, but in this case Lorenz just take another constant x prime equals to k x minus bt. Just he add a simple constant that is known as proportionality factor or constant factor k. Using this factor, they can solve all the problems. So, this k is also gives the explanation of second postulates or first postulates. That's why this is the acceptable. Now, I am going to details about the factor k. In this case, similarly, x prime and y prime, z prime are also remain constant, t remain constant. And in this case, when these two frames coincide at frame O, suppose a light is bounced and on measure the displacement c another one, then the equation becomes x equals to k of x prime plus vt prime. Then the light measured by the two observers from these two frames S and S prime will be, from S prime the observer measure the speed of light x equals to ct from S prime, because these two these fire burns when these two frames are in coincides, but after t second the light travels the distance x equals to ct, and another frame the observer measure x prime equals to ct prime. Just plugging the value of x and x prime in this equation and in our previous equation, we get Ct prime equals to k of x minus bt. Again, x equals to Ct, putting this, that is Ct prime equals to k, x equals to Ct, and taking k constant from this, then we get Ct prime equals to kt c minus b. So this is equation 1. Now another equation, that is in A equation we just put x equals to Ct and x prime equals to Ct prime. My dear student, this is x, we just put Ct, and x prime, that is Ct prime. Then what will be the equation? That is with the help of equation A, Ct equals to k Ct prime plus bt prime, taking the constant common factor, that is Ct equals to kt prime, t prime is taking constant, then you get kt prime equals to c plus b. So this is equation 2, and this is the equation. This equation start from our previous equation given in the previous syllabus, and this equation start from equation A. So if you observe clearly, then you can say from where Ct prime kx minus x prime I have got. This is the first equation from this first equation that is written by Lorenz, and this is the equation that we get from A. And if you multiply these two equations, equation 1 and 2, you will get, multiplying these two equations, you will get c square tt prime equals to k square tt prime c minus b and c plus b. You know that c minus b and c plus b gives another formula. Then you can write c square equals to k square c square minus b square, a minus b into a plus b. This is a simple relation, and cancelling tt prime from both sides, c square. Then you can write k square equals to, by taking this part in the dominant, that is k square equals to c square by c square minus b square. Now rearranging this equation, k equals to 1 by root over 1 minus b square by c square. So this is the factor. Now putting the factor k in equation 1, you will get x prime equals to x minus bt, x prime equals to x minus bt, root over 1 minus b square by c square. Now we can write y prime equals to y and z prime equals to z. Now another equation, plugging the value of x and x prime in equation 1, we get ct prime equals to ct minus bx by c. Taking c common from this factor, you can write ct minus bx by c square. In this case, just we have take the common factor c. So this is the t prime equals to t minus bx by c square, root over 1 minus b square by c square. So these are the Lorenz transformation. In this transformation, you know that the position and the time depends on the position with the velocity of the body. And now inverse Lorenz transformation, that means you have to take v in place of minus, you have to take minus b in place of b, and you have to take x, y, z in place of x prime, z prime and y prime. That means you have to consider in inverse way. You will get inverse law, x equals to x prime plus bt primes, root over 1 minus b square by c square, and y prime equals to y and z prime equals to z. Then you will get t equals to t prime plus bx prime by c square, root over 1 minus b square by c square. So these are three inverse transformation. So my dear student, today I have learned so many transformation and the inverse relation. So this is all. Now I am going to tell about homework. What is relativity? Number 1. Number 2, what are the limitation of Galileo transformation? And what is the success of Lorenz transformation? And the last one, what is inverse transformation? So this is all. Thank you all.